Hello guys, good evening. And now we will talk about how we handle structured data. That means the data that is coming in some structured format like JSON, and that is streaming data coming in real time. We call it as Spark structured streaming. In short, how you handle data that is streaming, that is coming in real time in Databricks using Apache Spark structured streaming. Okay. So streaming, first we will understand the streaming word. This is the process where unbounded flow of data, like it could be sensor data, it is continuous, like log files, social media data, data coming from various social media platforms, that is coming in real time. Now, if we want to process that data as it comes in real time, the regular data transformation tools like Spark, and we use Python on the Spark, we call it as PySpark, they are not enough. And another API of Spark called Structured Streaming API, it has some functionalities to handle data that is coming continuously. We will understand, and also we will see how to process that streaming data using this Apache Spark structured streaming on Databricks. Before that, we will talk about few functionalities. I'll quickly discuss about few things, right? I want to talk about the data streams. Just now we discussed the data streams, the continuous flow of data. This is called as data streams, where in Spark, not only Spark, in general, we define them as data streams. They'll be continuously coming. And now we need a mechanism which can handle this continuous flow for data processing. We have tools like Kafka, which continuously flow data. Let us say we are getting data from that some data stream like Kafka. Now using Spark structured streaming, what we can do is we can append this data to the existing data frames. And we already know this concept of data frames, which is nothing but arranging your data in form of tables. Now here there are two concepts again. To handle your data that is continuously coming, either you can use data stream API or you can use table API. This is nothing. Let us say some 3 messages came from Kafka, and each of the messages will be loaded into this table or data frame. When you use data stream API, which is nothing but in-memory table, message 1 goes to first row, message 2 goes to second row, and message 3 goes to third row. Now, if you use a table API, you have to create a table. Like on platforms like Databricks, you can make use of table API. You know, already in Databricks, you can create databases, and then tables in them. You can make use of table API. You have to create table in advance. The difference is when you use table API, you will create table in advance. Even before data comes, you will define schema of the table. When you use data stream API, you need not do that. Automatically, the data that comes will be arranged in some tabular format using data stream API. This is similar to the regular Spark batch processing we do. and there is no much difference. Now, what makes the difference is, as this data continuously comes, that will be appended to these tables. Now, let's say fourth message is coming. Already there is a table or a data stream with 3 rows. Now, fourth message, as it arrives, it will be appended as a fourth row. As fifth message comes, it will be appended as a fifth row. It is as simple as that. Only the name is different, the Spark structured streaming, but other functionalities, libraries, most of them which you use to process the real-time data are similar to Spark batch processing. Now, this Spark structured streaming comes with two different like functions, which allows you to write the data that comes continuously as a new rows. Now, before this, we will just talk about few things. How to handle the data streams. Data streams means the data that is continuously coming. That is streaming data. And we have batch data. The data that is static, it is not changing. Like if you have a batch data, you can read the data and you can apply your transformations on that data. We know that. Now here, to handle the continuously coming data, that is streaming data, we have two methods: recompute, and we have incremental processing. Incremental processing. Recompute, as new data arrives, whenever new data arrives, the entire data set is again recomputed. Whenever again a new value comes in, a row or a new message, again entire data set is recomputed. There are a lot of drawbacks for this method. It is computationally intensive and time consuming. Now, other way of processing the data streams or the continuously coming data is identifying and capturing only the latest entries or only new data since the last update. Capture only new data and apply your transformations on that. After that new data arrives, fetch that and apply your computations. That is incremental processing. Now, Spark structured streaming, like Spark, we have many other libraries which can process data that is coming continuously, streaming data. Like in Kafka, we have Kafka streams, Spark structured streaming, Apache Flink. And in Databricks, it uses Spark. So we will talk about Spark structured streaming now. Now, this Spark structured streaming follows this incremental processing. As data keeps on coming, let us say this is any data stream which is streaming data like Kafka, or you are reading a file using a data stream, or it could be a real-time data, right? So the new data will be keep on coming in and it will be streaming into the Spark structured streaming. Libraries, a few libraries makes the regular Spark as Spark structures streaming, and you can save them in data sync. And what is this data sync? Some storage or a database or a data warehouse. In Databricks, you can store it as a file or as a table. In local, You can save your data in the sinks like HDFS. And here in Databricks, we have DBFS and data warehouse, Unity data catalog. There you can save your data. So that's what Spark structured streaming can do. It can collect data and it will append that data to the table. As the new data comes, it adds new rows. And on this continuously changing table or data frame, you can apply your transformation. Once the data is transformed, you can write that into the data sink. Now, how Spark is doing that? Why regular Spark is not doing that? Only Spark structured streaming is doing that. There are two key functions in Spark structured streaming, guys, which are playing key role in reading the data stream and writing them as a new rows to the table, which in regular Spark we don't have. And those APIs which facilitates processing streaming data or Spark dot read data stream. This is one API. What it will do? It will allow processing existing data in table and new data as it arrives subsequently. All you have to do is spark.read data stream and mention your source table. If you are using table API, otherwise you mention your data frame, right? And as data comes in, it reads the data continuously. Or you can add trigger. You want to read your data in incremental batches. Let us say for every 2 minutes. You can add a trigger to the Spark read data stream. So for every 2 minutes, it will read the table. If you don't mention any schedule, by default, it is 500 milliseconds. So continuously, it will read the table for every 500 milliseconds and get all the new rows. Right? And then after transforming your data, you have this stream or Spark or whatever data frame you use. First, you make your transformation and write your data into the data frame. So let us call that data frame as streamdf. You read the data that is continuously coming, and after your transformation, you'll make the data available as a data frame. Now that data frame, you just say dot write stream. And to a table or to a data frame again. Dot write stream, dot table, and you will write to the target table. So these two APIs or functions in Spark structured streaming API allows you to work with continuously coming data, that is streaming data. See, the concept is incremental uploading of data. And what allows you, this function, spark.read data stream function, allows you to continuously read the data source and add them as a new rows. So every time as per your trigger, suppose if it's 2 minutes or a default trigger 500 milliseconds, you go and try to read the source table. Let us say initially you got some 5 rows only in your source table in first minute. In second minute, you might have some 10 rows. Suppose if trigger is not given as 2 minutes, the default trigger is 500 milliseconds, right? In next minute, you might find 15 rows. So it will continuously read and update as data comes subsequently. And here, write data stream, it can also read and continuously write. So that is the difference. These two are key functionalities or libraries which make Spark as Spark structured streaming. Now let us say I have table 1, right? As new data comes, I'll say Spark dot read stream and write into table 1. And here I can mention trigger. Trigger equal to some 2 minutes, or if I leave the just as trigger equal to true, it will take the default 500 milliseconds trigger. So this is my table. All the data that is coming from Kafka, Spark reads and writes into the table. So let's say Kafka data is coming into the table. It reads the table continuously. And then we are creating a stream data frame. So every minute or according to the trigger schedule, the data will be loaded into this data frame. The latest table will be loaded into the data frame. Now table 2, which you can also call as sync at this point of time. Here what you will do, stream df, because now all the latest data with the latest updates to the table, it is written into your data frame, which called stream data frame. Dot write stream. See, and then dot table 2. Now in between, you can apply your transformations on this stream data frame. If you want to average, aggregate, clean the data as it comes, you want to do some rolling averages. So all these kind of things, summarize the data, these kind of transformations you can apply on in between this data frame. Once you feel that your transformations are done on the data frame, just say write stream and you select this and say dot write stream table and give your sync table. And now all the transform data. And what transform data? The transformation that was done in real time. Real time data processing, it's nothing but in real time you process data and you save that data. Now let us see how we can do that on Databricks. Yeah, I'm on my Databricks. This is Databricks free trial, and it's not community edition. And for new users, recently Databricks is not providing community editions. However, for old users, they can still use the community edition. And this is the Databricks free trial. And after free trial, obviously I have to upgrade to the like pay as you go Databricks. And here the thing is, you don't have the catalog by default. You have to create one catalog. You don't have the DBFS file system. So you have to create a data catalog. Instead of data catalog, you can add your S3 bucket or Azure blob storage or the GCP cloud storage, anything. And if you want to make use of DBFS file system, you can also do that, but you have to create a catalog. Now I'll click on this catalog. See, you just click on create a catalog. Now, if you want to bring in data from your AWS S3 or any other place, create an external location, or even DBFS. You can create an external location. Now I'm just creating a catalog. Give some name like streaming lab. Type standard. I'm not creating this. Let us say streaming demo instead. Create. I'll create this. That's it. You have this streaming demo. Now you can make use of this catalog. I mean, the place where you can save your files. By default, you have a workspace and some default is there. Default data warehouse. Workspace is there, but as a catalog, I mean, where you can save your files as it is. Yes, you have a default one. You can make use of that, or you can create your own data catalog like we have done. So let me use this workspace streaming lab, and there I have default schema. My schema name is default, and also there is information schema which can be used by Databricks itself to save the information metadata, that is information schema, and to work, that is to create tables and all, we can use default schema. Now going back to workspace, I created this notebook. See, I'm using this catalog called streaming lab, and already there is a schema called default. If you want, you can create your own schema also. And then volume name streaming demo. What is this volume? This is storage. Now, earlier we used to refer it as DBFS. Now, since this we created an Unity catalog, we just call it as volume. Now I am creating this volume. See, if this volume is not there, I need to create it. Volume name I am giving, and then after creating the volume, because data catalog already we created from the console, and the default schema is there, but I didn't created volume from there. I'm just giving these variables. Before I go and create folders in that path, I'm taking care that if there is such kind of path, I'm deleting it. If earlier, if this path is there, I'll just delete it, and then I'll create this volume. After that, in that path, I'm creating folders called input, checkpoint, schema, and output. I'll run this. True. Now, why these? We will go to this presentation. Okay, if you see here in the screen, input location, which I have created input folder, and it's obvious to read all the streaming data, I'll put it in input location. Now, as your Spark structured streaming reads data from input location, it will save the data in the checkpoint location. What is this checkpoint location? Metadata. Like what is the status, current status, and how to read the data. For example, if Spark experiences some crash, if it want to start over again, the details that it saved in the checkpoint will help it to again start over from where it has stopped. And also, It helps for the Spark to avoid reading messages again. For example, to some glitches or to some crashes, if Spark try to read the data again, it should be able to detect the duplicates. It should not read the same data again. Now, how Spark can know all these details? By saving all its metadata in the checkpoint. It will understand up to like where it has collected data, and accordingly it will start reading the data again. So metadata will be helpful, and always in structured streaming you have to give a location to store the metadata, that is checkpoint. So we created this checkpoint location, and then input location, and also output location. So this is just to tell you that suppose if Spark has stopped for some reason, from here it will restore the state. Again, it will start reading. And it will save the data into persistent state, which is nothing but into data frames. And from there, you can apply transformations. Okay, now see input for input data, checkpoint, and the schema. We know the schema we have, and then output, sync, where we finally transform and write our data. I have run it, and you can see the message as true. I'm just ensuring that if there are any table which I am going to further use as instructor counts, if it is there, I'll just drop it. Okay, then since I'm using the free trial edition to bring in data as a streaming, I have to connect streaming solutions like Kafka or from clouds like AWS, Azure, or GCP. Using GCP PubSub or using AWS Kinesis or Kafka, you can stream data. Now I didn't associated my Databricks with any such kind of cloud. So what I'm doing, I'm manually inserting the data into the input location. See, I created some JSON data. In micro batches, I am loading the data into the input location. See, input. There, what I'm doing, I am importing JSON time and creating some synthetic data with these fields: course ID, course name, instructor, enrolled on. You can see the date. And this is my first batch of data. This is the second batch of data which I am sending. And there is a for loop which sends this data, converts this and sends to this location, input / batch data. And if already that data is there, we are saying overwrite equal to true. Run this. And you can see wrote batch 0. And then batch 1. Batch 0 has 2 messages. And that's why it took 204 bytes. Whereas batch 1, this data, this is 102 bytes. Now I have this data. Now I am creating a data frame, right? I can also create a table and write this data into table also. Then I am using table API, but here I am using data frame API. So what I am saying, I am creating a schema with course ID, course name, instructor, enrolled on. I'm creating the structured type, and I'm creating a stream DF and loading all the data that comes into this input path into this stream DF. And it writes one file at a time, maximum files per trigger. And also we are checking the location checkpoint. So this is the checkpoint location. Run it. See, checkpointing to volumes, it gave the checkpointing location. And we have ingested 3 messages, but in 2 batches. And you can see all those 3 rows in the table. But actually, it says table. It is stream DF data frame. And then we are doing some transformations on this data frame. See stream DF on this. I'm grouping by instructor and calculating total courses. Now we have aggregated this. Now aggregated data, say aggregated data frame, I am writing into this write stream. Run it. So done. Now I am using SQL statement to check the instructor counts. You see, in default location, it creates a table called instructor counts. Here I am using dot table option. But if when I read, I can also use the dot table option, but we have used the data frame. Now the thing we discussed, the small change here. Now all the streaming data, as it arrives, it comes to data frame. What data frame? Stream DF. And from stream DF, we are creating aggregate DF. We are applying some transformation. Data as comes in real time, this aggregation will happen continuously. And aggregate DF is now our transformed data. Then what I am doing, I am writing using dot write stream. So above I have used dot read stream, spark dot read stream. It reads the schema, arranges the data into the schema, and on that we have applied some transformation. Now dot write stream, it requires table actually, this one. This is the main thing to write. In this data catalog, in default schema, we are creating a table called instructor counts. So we don't have an input table, but eventually in output, we are saying dot table instructor counts. And other options we have to give. Output mode is a complete. And also trigger what we are giving, dot available equal to true. So when you say dot available equal to true, it processes all the available data in that single micro batch. Now, if you don't want that, sorry, if you don't want that, you can mention your own time, like 5 minutes, 2 minutes. So now I have only 3 rows. I'm saying trigger available now equal to true. So it reads all the available data. And output mode, we are saying complete. That means target table is overwritten with each batch. Another option we can give as default. Sorry, not default, append. If you say output mode append, now whatever that is there in the data frame, it will append to the table. Now, if output mode is complete, in this case, it will override the data. So now these are the things which you have to look into. Now dot write stream will read data from the data frame, and according to the trigger which you gave, if you don't give anything here, if you just say dot trigger, it will take by default 500 milliseconds as the time. You can also mention the time, 2 minutes, 5 minutes, or available now equal to true. That means it takes all the data. And then output mode complete. Here you can also give append. Complete means whatever rows are available in the data frame, it will take them and overwrite to the existing things in the table. Append means it will append as a new rows rather than overwriting. Then dot option. You are giving checkpoint location to save the metadata. Okay, already we ran it. Now we will just run this SQL to select. See, from this data catalog streaming lab, and we have schema default, and just now we created instructor counts which should have aggregated data. I'll run this. See, we have this. Now I am writing some additional batches. Already those cells are running. That means dot read stream is already running. Now you see I'm writing some C4, C5, C6 again, additional batches. It is still the same because we didn't given the trigger, right? Available. If I say trigger equal to some time, according to the time, it will give you the aggregated results. And describe history. And you can see what happened, how data inserted, at what timestamps, user ID, username, which is my Databricks user ID and name, and the operation, streaming update, created table, and then streaming update. Okay. And you can see the output mode complete. Now I can remove the dataset path, drop the table if exists. Again, I'll just clean up. So that is like very small hands-on, intended you to understand structured streaming and the two important functions, that is read stream, write stream, and the other functionalities which you have to give in write stream, like trigger, output, options, checkpoint location. Yeah. And using this Spark structure streaming, not only in Databricks, even in your local, you can process the streaming data. Yeah, thank you.